Good morning, everyone. I hope you're all enjoying the conference so far. That was a fantastic talk from Val. I'm not sure I can top Space Cat, but I'm going to do my level best. I'm Léonie Watson. Until very recently, actually worked with Government Digital Service. My other job is working with the Paciello Group as an accessibility engineer, mostly spending my time working with the W3C on different specifications, but also pulling apart things both new and old to see how we can make them more accessible and come up with some practical solutions to help us make the web a more inclusive place. So today I am going to talk a little bit about accessibility. And, oops.
5.
There we go.
4, 3, 2, 1, go. You're only supposed to blow the bloody doors off.
A classic clip from the 1969 film The Italian Job with Michael Caine. At this point in this talk, I usually say, but often this is how things feel when we're working on the web. What I should actually say is this is often how it feels when I'm trying to start this talk, but there we go. It's really easy, I think, when we're working on the web, we're working to timeline, we're working to requirements that perhaps aren't as clearly defined as we'd like them to be. A whole bunch of other pressures mean that often we try to do the right thing in the time with the resources that we've got available, but quite often we end up blowing things up. From an accessibility point of view, this law of unintended consequences, if you like, can have quite a serious impact, not just on someone's convenience to interact with an experience or a product, but actually to interact with it at all. So what I'd like to do today is tell you a little bit about accessibility mechanics, how an assistive technology like a screen reader works with the browser, and then give you 5 ways to avoid blowing things up entirely for screen reader users and keyboard users. If you're not familiar, a screen reader is a piece of software that translates what's on screen to synthetic speech, so that people who are blind or partially sighted, or people who prefer to listen to content, perhaps because they're dyslexic or on the autistic spectrum, can use to access content in a non-visual way. And they're pretty capable pieces of technology. They can, in a very simple sense, read text on the page.
Heading level 1 using the ARIA current attribute posted in link code things on January 14, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem.
But screen readers are not just things that read text from top to bottom. They like HTML, and they can pick up a lot of information from the browser that makes it possible for someone who uses a screen reader to navigate between different kinds of HTML element, like headings, for example.
Accessibility object model AOM heading level 2 link. Accessible SVG line graphs heading level 2 link.
So there you can hear the screen reader picking up all kinds of information, the different heading levels, including the numbers, and also the links that are inside those particular headings. Another example is using buttons. Sorry, this is giving me no end of grief today. I really should learn not to do these kind of talks, I think.
Category button collapsed. Tags button collapsed. Another blogs button collapsed. Conferences button collapsed.
So there, the screen reader is recognizing not only the button elements and describing them as such, but also, in this case, recognizing that those buttons have expand and collapse capability and informing the user that they're in the collapsed state currently. And all this information is picked up directly from the browser. Screen readers and browsers work in really close harmony with each other. So if we take a couple of elements like details and summary, for example, we load them into the browser. The browser passes the content and creates the document object model. And then, depending on the browser, it does a number of other things. We get a visual rendering. So in Edge, for example, where these elements are not yet implemented, we just get a flat rendering of the content that's otherwise going to be disclosed. In something like Firefox, where these elements are implemented, we get a visual rendering that suits a disclosure widget. But at this point, the browser also starts providing the expected interaction. You can click on this element and get the content to be disclosed. And the browser also takes care of the keyboard interaction for us. So as developers, we don't need to think about that happening. We just know that someone with a keyboard or a mouse or any other input device can access these particular elements. The browser also gets busy in another way. It creates an accessibility tree that's a sister tree structure to the DOM, but it only contains accessibility information. So if we were to look at the accessibility tree for the summary element, we'd find that in this case it has a role of button. That's kind of the logical UI component that it represents, because you can click on it or interact with it to open the widget. It also has information about the fact that it's expandable, although at this point it's in a collapsed state, and it's focusable. So again, someone using a keyboard can actually get at that piece of information. Something like a screen reader takes all of that information out of the browser's accessibility tree, and that's what it uses to convey that information to users.
Data. Tequila ... button collapsed. Enter. Tequila ... button expanded. Makes me happy.
So again, we get that information. We know it's a button. That sets up the expectation to the user that you can interact with it. The collapsed information conveys something about the state, which also helps as a cue to know how to interact with this. And when we do, we get the information on the other side of the disclosure widget. The way screen readers get at this information is through one of a number of platform accessibility APIs. There is at least one for all common platforms: Windows, macOS, iOS, Android, and Linux. And these APIs are only available at the moment at the software level. So as developers, we can't use them. They are exclusively used by the operating system and software applications like screen readers and other assistive technologies. But these APIs let the screen reader query specific information about objects that are on screen. Before these APIs were a thing, Microsoft was the first to introduce one with Windows 95 back in the 90s. Screen readers, believe it or not, used to guess a lot of the time. They would intercept the video signal on its way to the video output device, and then they would do things like, if there's a slightly oblong shaped thing on screen and it's on a horizontal plane with a number of similarly shaped objects, I'm going to guess that that's a menu. And I'm going to sort of guess that the thing in the middle of it is probably some text, and that's probably the thing I want to announce to tell the user that they're dealing with a menu of that particular name. That was a really inefficient way to do things. So like all good APIs, what these platform accessibility APIs enable the software manufacturers, the screen reader users to do is query something and say, hey, tell me about yourself. What is your role? What kind of component are you? What is your state at the moment? And then use that information to help users understand content. Most elements have all this information attached to them. Pretty much every single element except two has an implicit role. So we saw the headings earlier being announced, or heard the heading earlier being announced. That's because all the H tags have an implicit role of heading. Links have an implicit role of, it'll come as no surprise, link. But div and span elements are what we call neutral elements because they don't have any implicitly strong role of their own. They're just completely inert. So if we take an example of a couple of div and spans, say pretending to be a toolbar, we've scripted it and styled it to look the part, but at the HTML level, it's just still some divs and spans. It tends to have a slightly unexpected outcome for people using screen readers.
Data. Bold. Italic.
Which is to say that the screen reader doesn't really care too much about the CSS in this context. The scripting is still present, but because the screen reader is only aware of divs and spans that have no particular role, it just treats the content like plain text. So there's no cue that this thing can be interacted with, no indication that it's actually a toolbar or a menu bar or something of the sort. So in situations like these, we need a way of polyfilling accessibility information, because we use divs and spans a lot as the building blocks for all sorts of different things. perhaps because they don't exist in HTML, like a set of tab panels, or because we're using a framework like React, which seems to take great delight in throwing piles of divs and spans at things when there are otherwise perfectly good HTML elements at its disposal. But if we do find ourselves in those situations, we can use ARIA. It stands for Accessible Rich Internet Applications. And it's a set of attributes that can be used to polyfill missing semantic information when we need it to. It's done through two different avenues. There's the role attribute, and there are more than 70 different values in the ARIA 1.1 specification. And they represent pretty much every kind of UI component that you could want to produce. Simple things like checkboxes and radio buttons, more complex things like progress bars, menu bars, toolbars, tree grids, all sorts of things. But when you need to identify a UI component as having a particular role or purpose, this is the way to do it when those semantics don't exist for whatever reason. There are also a number of ARIA prefixed attributes, and these are the things that we can use to communicate characteristics, properties, and state of a particular widget. ARIA pressed, for example, will indicate when a button has been toggled on or off. ARIA controls indicates when one thing on a screen controls another piece of content. There are also more than 40-odd of these different attributes that let you indicate state. Do things like label elements. So ARIA label, for example, lets you apply a string that creates a label for an element, so a screen reader user is hearing that label when they focus on the particular element. So this is how it works, really. The browser passes the HTML, it creates the DOM. It then uses the information in the DOM to create the accessibility tree. The screen reader takes the information from the accessibility tree and enables the user to access it. If the DOM gets updated because we've just reloaded part or all of it, or because it's changed in response to a user interaction, then the browser takes that updated DOM, updates the accessibility tree, and meanwhile, the screen reader is listening out for change events in the accessibility tree that let it then communicate those changes or that changed information to the user. And it's a pretty well-structured, well-oiled process. This works really well when we're dealing with HTML and sometimes enhanced HTML with ARIA. So our first way of avoiding how to blow things up, particularly for screen reader users and keyboard users on the internet. The first one, and this might sound a little strange, is actually don't use ARIA. Time and time again, I've come across websites that otherwise would have been pretty well accessible, certainly very usable for people who use a screen reader or have to stick to a keyboard. And then a developer has very conscientiously and very thoughtfully realized that ARIA is an accessibility specification and it can help make things more accessible, and has completely inadvertently caused a little bit of a problem along the way. There's actually another reason why not using ARIA unless you have to is a really good thing to bear in mind. And that's because it adds complexity. So I'll show you a bit of an example. If we take a span element and for reasons best known to ourselves, we decide we want to make that span element a button. We can style it and make it look the part, but it'll probably come as no surprise to you that the span element is inert. You can't focus on it. So a keyboard user has this experience. They don't. They can't get to it. So that's fail number one in terms of blowing things up. Span and div elements are not focusable by default, so keyboard users basically can't get to them and can't interact with them. If we see what screen readers do with it, it's pretty much similar to that toolbar example.
Tequila.
We don't get any sign that this is a button. We just get the single word, the label of the button, and no clue as to what this thing actually is, let alone that it can be interacted with. So we can start polyfilling that semantic information. We can use the role attribute with the value of button. That will expose this span element as a button in the accessibility tree. It doesn't change the DOM, it just changes the accessibility tree. And then we can use tab index with a value of 0 to make it keyboard focusable, which is fine. It does the job from an accessibility point of view. A screen reader user now has this experience.
Tab, tequila button.
So now they know that it's a button that they're dealing with and that tequila is the label of the button. Alternatively, we could have used the button element. And then we wouldn't have had to add in those two particular attributes. And the experience for a screen reader user and a keyboard user would have been exactly the same.
Data tab tequila button.
In this instance, we were only adding in a couple of extra attributes, the role and tab index attributes, and it's not too much of a headache. But if we're talking about polyfilling an entire app interface or an entire chunk of a page or a complex widget, we're talking about adding a lot of extra moving parts. I did a quick back-of-napkin experiment a few years ago and tried to recreate a link. And as far as you can recreate a link, there are certain things that for security reasons you're not able to recreate in a custom link. But it added about 20% extra code just to do what I was trying to do. A silly example, perhaps. But if you think about adding 20% extra code just to recreate something simple like an anchor element, imagine how much extra code you're going to be adding when you want to, as I say, do something more complex, or you're talking about the entirety of a complex web app interface. We start to add in a lot of extra work for ourselves and a lot more moving parts. That means things ultimately are a lot more brittle. Because a lot of the ARIA information is not exposed visually, it's really easy to not update that information, get it wrong, and we don't see that during testing. In other words, it's just that simple thing of the more moving parts there are, the more brittle it becomes, the more testing you've got to do, or the more rigorous you've got to make sure your testing is. So if you can keep things simple, use native HTML wherever you can, let the browser do most of the hard work for you on the accessibility front, you'll end up with something that's, generally speaking, a lot more accessible and certainly a lot more reliable. 4, don't break native semantics. The role attribute lets us define the role of any element. So even one that has its own implicit role, we can override that information any way we like. And you can start to have some really strange consequences when you start doing that. For example, if we were to take a button and to give it the role attribute with the value of heading, add in the ARIA prefixed attribute for level, in this case we'll say it's a level 1 heading, something very interesting happens. Visually on screen, it starts to, it still looks like a button, it functions like a button, but for a screen reader user, it's really not a button at all.
Data heading level 1 tequila.
Now, I can't think of any good reason why anybody in their right minds would actually decide to repurpose a button and tell a screen reader users it was a heading. It's a silly example, but the point remains. It's very, very easy to overwrite implicit native semantics with something completely different, and that has very unintended consequences for someone who isn't able to look at the content, but is instead relying on that information. So when you start using the role attribute to change the purpose, the conveyed purpose of something on the accessibility layer, make sure you're not, in doing so, getting rid of some really useful implicit semantics. Generally speaking, a thing is built for a particular purpose, and that purpose is pretty well tried and tested on the web. So it's not to say don't do it. There are certain times when it's worthwhile, but think very carefully before you do. 3, make it work with a keyboard. Keyboard users actually take up a remarkable chunk of the average web-using audience. People use keyboards for all sorts of reasons, not just for disability-related ones. Many developers, actually, and you guys may count yourselves among this, prefer to use the keyboard a lot of the time over a mouse because it's just more convenient to keep your hands on the keyboard than it is to keep switching between a trackpad and a mouse and the keyboard. So keyboard accessibility is possibly the single most important thing you could do in accessibility terms. It basically means that sometimes, as developers, we've got to supplement existing interaction. A really common design pattern we see is taking a link as the starting point and converting it into a button. So we take an anchor element, it has keyboard focus because the browser supplies that for links, but then we style it to look like a button and we give it other button-type behavior. An interesting difference between a link and a button is that natively the browser makes a link actionable with the enter key, and a button is actionable with either the enter key or the space key. So if we're going to repurpose a link to become a button, we need to make sure that our scripting just adds that extra keyboard ability in there, because that's what keyboard users will be expecting. So we listen out for the key code for the space key as well, and make sure that when someone interacts with this link using that the space key, The script is therefore capable of executing whatever action is necessary. Sometimes, like our earlier example, if we're going to start repurposing an inert element like a span, we've got to provide all the interaction. So again, in this case, we need to make sure that it's focusable using the tab index attribute, but we also need to make sure that actually the interaction for keyboard users is supported too. In this case, we listen for both the enter and space key codes, and when either of those is detected, we make sure that the expected functionality is triggered. The basic rule of thumb is that whenever you are creating a custom widget or a component, or these days a custom element, and something needs to be interactive, it's down to you to provide the expected keyboard interaction, whether that's supplementing it or starting from scratch, but that's a responsibility that we have very much as developers. So when we do, we get some interesting and good things happening.
Data.
Tab, tequila button collapsed. Enter, expanded. Blank. Makes me happy.
I can't help thinking I should have changed all these examples to beer somehow. Tequila feels a bit traitorous. Second to last way of avoiding blowing things up is not to trigger something called applications mode. Screen readers, when they are interacting with software, have a very limited set of commands at their disposal. You can tab through items or shift tab if you want to go in the reverse direction. You can use the enter or space keys to activate things, and sometimes the arrow keys. On the web, as we saw earlier, screen readers have got access to many, many more ways of navigating content. You saw headings and buttons, but you can also navigate by tables, by graphics, by lists, list items, forms, form fields, different kinds of form fields, so it'll differentiate between edit fields and buttons and radio buttons. There are literally hundreds of shortcut commands that most screen readers make available to their users for navigating around. When you use the application role, you strip the screen reader of its capacity to use any of those shortcuts on the web, and you take it back to the same form of interaction that it has available in software. So, and in some respects, I almost think this should be the number one way of blowing things up. If you put the role of application on the body element for something that you are building, you then will have to provide all the keyboard interaction, shortcuts, navigational hooks that screen reader users expect using JavaScript, which is a hell of an undertaking. And that even assumes you know what it is needs to be provided. And the chances of that are fairly slim because screen readers, like browsers, do some things the same and an awful lot of things a little bit differently. So putting the application role on the body is definitely something you want to avoid. Actually, putting it anywhere is pretty much something you want to avoid. In I guess, 10 years of this role being available in the ARIA specifications, I've almost never come across a good use case for using the application role. So the reason for this is particularly complicated by the way different screen readers intercept keys. On Mac, what happens is that a user presses a key, and if that keystroke isn't recognized or needed by the browser or what's running in the browser, then it gets sent back to the screen reader, and there it executes whatever screen reader command is appropriate. On Windows, it happens the other way around. A key gets pressed, and the screen reader gets first dibs on it. So the screen reader says, hey, I want that keystroke, and if it wants it, it'll execute its command, and it won't pass that keystroke back through to the browser and the content that's running in it. As you probably gathered from my earlier mention of keyboard shortcuts, almost every single key on the keyboard is taken up in most screen readers by some form of shortcut or another. So this causes a huge complication when it comes to scripting that behavior if you use the application's role. You've not only got to be aware of the different paradigms for the keyboard intercept on different platforms, but also aware of all the different shortcuts in all the different screen readers that you might need to cater for. So it's a pretty big nightmare from a development point of view and certainly from a UX point of view for a screen reader user. The real kicker about applications mode is that it isn't just the application role that does this. There's a whole bunch of them that will trigger effectively the same mode. Things like tablist, progress bar, menu bar will all effectively put the screen reader into the same application mode state and lead you to need to provide the keyboard interaction. There is a little bit of a difference, but here's an example of a screen reader trying to interact with a set of tab panels that uses the tablist role, but with none of that extra keyboard interaction provided.
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element.
And that's it. The screen reader user can't get any further. It has no ability to cycle through the tabs because the screen reader shortcuts have been stripped away and there's no scripting to provide that interaction. So at this point, all the user can do is just use the tab key again to move past the content that's displayed on screen. They'll have no way of actually reading that content because text isn't focusable, so the screen reader can't use any of its crafty shortcuts to get the user to the text in order to read it. So it really is a complete showstopper in terms of accessibility interaction. Salvation comes in the fact that all of these things, progress bars, menu bars, tab lists, and so on, are pretty well recognized and documented design patterns. The ARIA Authoring Practices Guide, APG, is a really good source of these accessible design patterns. And the APG will tell you what kind of keyboard interaction is expected for a set of tab panels or a progress bar or any of the other of these UI components. It'll tell you what ARIA you need to make them accessible as well. So because although triggering applications mode is generally a bit of a dicey thing to do, in the case of these kind of roles, because the design patterns exist, we know exactly what we need to do as developers to make these things accessible. So we're taking the guesswork out of it. Whereas applications role leaves you to have to provide everything and do loads and loads of hard work. With these particular instances, what we need to do is pretty well documented and reasonably straightforward to implement. And the difference when we do means that someone using a screen reader and a keyboard can access all the information.
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element. Reposado tab selected, use JAWS key plus Alt plus M to move to controlled element. Joven tab selected, use JAWS key plus Alt plus M to move to controlled element.
So as well as finally, happily being able to find out about all the different kinds of tequila, you might also have noticed another thing that was being announced there, the ability to move to the controlled element. That comes courtesy of another ARIA attribute, ARIA controls. And it basically says this tab controls that content. So the user, screen reader user, could have used a simple shortcut provided by the screen reader to jump straight to the content of the tab panel that's displayed on screen. So adding in that keyboard interaction suddenly makes this much more available and usable to someone who happens to use a screen reader. Finally, our last way of not blowing things up. This one is a bit of a look to the future because there is a JavaScript accessibility API being incubated at the moment at the W3C. And it's one of those cases where with great power comes great responsibility. The accessibility object model is a specification, as I said, in reasonably early incubation at the moment. And it's a JavaScript API that will let us as developers interact directly with the browser's accessibility tree. So at the moment, we have to put ARIA into the HTML, which gets put into the DOM, which the browser then translates into the accessibility tree. Once we're able to interact directly with the accessibility tree, there'll be complete separation between the DOM and the accessibility tree. So in the most extreme example, we'll actually be able to add nodes to the accessibility tree that don't exist in the DOM. So as developers, we're going to be in a position where we have enormous and pretty exciting capability to do things from an accessibility point of view. But we're also going to have the responsibility to make sure that things don't get completely mismatched between the DOM and the accessibility tree. We take on effectively responsibility for something the browser does automatically for us. Some of the use cases for the accessibility object model are really strong. For example, being able to encapsulate accessibility into web components, particularly custom elements, so that we actually apply the ARIA properties to the shadow root is really a useful thing to be able to do. Instead of having to put ARIA properties outside of that, we can encapsulate the accessibility. So when someone uses a custom element, we keep the HTML and the DOM really nice and clean and simple. It's not sprouting extra ARIA all over the place. So that's a really good use case for the accessibility object model. It'll also allow us to define relationships that don't need idrefs as references. So at the moment, if we want to use something like, say, ARIA described by, which points to the ID value of another piece of content on the page and creates an accessible description for an element, we have to make sure that there's an ID attribute on the thing we want to reference. And again, that can kind of clutter up our code. It stops it from being as clean and as simple as we'd like it to be. And the AOM will effectively let us define that kind of relationship at the accessibility layer just by interacting with the accessibility tree. It's the last use case for the AOM, though, that is perhaps the one that we need to give most reflection. It's going to be possible for us as developers to identify and detect events from assistive technologies like screen readers, but also others like screen magnifiers and speech recognition tools. At first glance, this sounds like a fantastic opportunity. In the same way we listen for other kinds of events from mice or keyboard and we use them as the triggers for different actions, it sounds like a great idea that we would be able to do the same for other forms of input. The danger we've got here is that that very strong use case comes into conflict with privacy. If you're using a mouse, it doesn't really tell you anything about the person wielding the mouse. Same with a keyboard. But as soon as we enable ways to identify that somebody is using a particular kind of assistive technology, like a screen reader, we start to know something about that person in a very, very personal way, that they have a disability of some description. And disability is one of those pieces of information that, like gender, orientation, faith, race, we actually need to protect with the same degree of commitment that we do all other forms of personal information on the web. So this is one to watch, because as the AOM becomes further developed, more mature, and it almost certainly will because it does add huge advantages for us as developers, we've got to be very careful that when we have that capability, when we have that power, we don't do the one thing that could well stop things in their tracks completely for assistive technology users, and that's wield that information about the fact they're using a screen reader to the worst effect. And developers who have good intentions, and yep, that's most of us, I have no trouble with that particular level of trust. But sadly, we live in a world where we know that that kind of information isn't always wielded well. A very recent example where this has been discussed, someone had recently applied for a job, and the recruitment agent had put them in touch with the employer, and in the course of arranging an interview, the person I was talking to had indicated that they were blind. The next thing they know is that they've got an email from the recruitment agent furiously asking why they hadn't explained that they had a disability, because if they had, they would never have put them forward for the job. It's a pretty terrible set of circumstances. It's not too much of a leap of faith to imagine that that recruitment agent might well have decided to use a technology like the AOM simply to block people like that from their website. But that has all yet to come, and I have great faith in our developer community to do the right thing, because the web is an interesting and innovative place, and developers, if I know one thing about us as a community at all, is that we want to build things that work. We want to create good experiences for as many people as we possibly can. So I hope this has given you 5 ways to think about or avoid really blowing things up on the web when you didn't mean to, and in the process, creating some good, accessible user experiences. And I'll leave you with just one final thought, which is, don't worry about blowing stuff up. We all do it. We all fail. And actually, if you fail, it generally means that you were trying to do something you hadn't done before, and that's pretty much to be commended, in my opinion. And when it comes to accessibility, you may feel that there's perhaps a little bit of extra pressure not to fail because the consequences can be so much more serious for someone. But the thing about accessibility is that it doesn't have to be perfect. It just has to be a little bit better than yesterday. Thank you.